Hello, everyone. Welcome to the next episode of our IEEE Communication Society podcast series. So this is number 16. This is a bit different than our regular format where we actually have people and we, have discussions and talk about many different things. Today, in this particular episode, I would like to talk about one of our books that has been recently published by Elsewhere. So the topic is basically this: integrated sensing and communications for future wireless networks. So I know I should have had a hard copy, but here we are with the book itself, in some sort of digital format. So this is edited by myself. I'm Professor Aaron Kaushik from the Manchester Met in the UK. And we have several sort of contributors of different chapters in the book. So I would like to talk about the technology itself. As you know, that ISAC is a very important technology, which, short form for integrated sensing and communications. So this has been brought forward as one of the sort of key technologies, key usage scenarios of 6G framework that we have, the IMT 2030 framework that we call it. So it becomes more important than ever to make our systems more multifunctional. So basically getting on board your sensing capabilities as well. So not just having the communication infrastructure, but actually combining different technologies together, right? So you have your sensing, communication, and perhaps you can even bring on board positioning, localization, many other sort of aspects of certain technologies as well. But in this particular episode, we talk about how we integrate sensing and communication, how we can enable this technology, let's say for our 6G and beyond sort of infrastructure that we talk about. So I would like to mention, the book consists of different sort of chapters and different parts as well. Actually, it has been divided into different parts. So first we start with the first chapter. So that one is basically introduction to the ISAC, right, to the technology itself. So how it is useful for our future generation of networks. We also try to provide some sort of historical overview with it. So this chapter has been authored by our colleagues Soumya Prakash Dash and myself, and also Ana Garcia Armada as well. So we discuss about how sensing or radar sensing has been very important for many years previously, and also how communication systems have also been sort of developed in parallel, and how the amalgamation or the combination of these two technologies is going to be very advantageous, very beneficial for our future wireless networks as well. And we discuss about some waveform design, some case studies, and also the different combinations. For example, how ISAC can utilize edge intelligence, how ISAC can utilize, let's say, reconfigurable intelligent surfaces, or intelligent meta surfaces in general. How ISAC can utilize, let's say, it can aid non-trusted networks, right? Which is basically another of the key usage scenarios that we need to think about, is basically providing ubiquitous and global connectivity. So how ISAC and, let's say, non-trusted networks can come together. And even in non-trusted networks, you got different sort of technologies, right? So you have aerial NTN, your HAPS, LAPS, MAPS, these sort of flying platforms, and so on. And also you go to your different like satellite-based connectivity. So from LEO satellites, GEO satellites, MEO satellites, or whatever is the range that we have. And how ISAC is also useful when we intertwine this technology with centimeter wave bands, let's say, right? I mean, going beyond sub 6 gigahertz band. So operating somewhere about 8 gigahertz, 9, 10 gigahertz sort of frequencies, and sub-terahertz as well. So in some geographical locations, we may require sub-terahertz frequencies as well. And how ISAC can be used for like artificial intelligence and machine learning, how actually ISAC can provide more benefits using AI and machine learning methods and so on. So that's the first chapter that we actually talk about. Then we start with the first part of the book, basically after the introduction. So we talk about the key enablers, which is intelligent meta surfaces for ISAC. So how these meta surfaces can be useful for, let's say, ISAC, right? So first in the row, we have chapter second, which is basically holographic integrated sensing and communication. So that is authored by Haobo Zhang, Hongliang Zhang, Boyati, and Lingyang Song. So these are our colleagues in Peking University. So basically they talk about why, let's say, reconfigurable holographic surfaces. So this is another very key technology that we are taking forward. how the technology is essential, let's say, for our future generation of wireless networks, and how this sort of holographic beamforming can actually be useful for ISAC. So this is again quite important aspect to have the sort of dynamic and intelligent transmission and reception of your signal. And mind you, this signal is actually dual function, a bit more complex than our general characteristics of the signals that we were talking about. So how holographic beamforming can actually enable ISAC signaling. So that is one of the aspects that we discussed. And then there is some sort of problem that they discuss about how to optimize this holographic beamforming, keeping in mind that you have the ISAC design, the ISAC signaling, and you optimize, let's say, for digital, for analog, and overall how you actually implement holographic beamforming at the end with your analog digital beamforming that you got. And then you test the performance in terms of conversions, in terms of different cost effectiveness parameters, and so on. So that's basically this chapter actually deals with, and some simulation results and so on, like basically around these performance metrics that I just mentioned. And they also discuss about one of the prototypes of the holographic ISAC systems and some hardware modules as well in this chapter. So it's a very interesting chapter. I would really suggest you to please, if you're interested into holographic beamforming for ISAC, it's a very interesting chapter. Then chapter 3, the next one in the row, is basically RIS-aided or RIS-empowered. RIS is basically your reconfigurable intelligent surfaces, empowered integrated sensing and communication. So that one is basically authored by Ming Li, Rang Liu, Hong Hao Lu, and Qian Liu. So these are our colleagues in Dalian University of Technology. And they also provide some discussion about the RIS technology itself, the architecture and so on, and how actually RIS can assist communication sensing, right? So the joint communication and sensing that we got. And we also have, let's say, how we can actually, deal with different case studies of this RIS-assisted, joint communication system and sensing, combined with sensing. And they also, try to provide some sort of near field based scenarios as well, because it's quite important that we are actually moving from far field to near field. Or we can have some sort of hybrid scenarios where you have mix of near field and far field, and stuff like that. Some sort of algorithmic design they try to provide for this particular chapter. And then we have part 2. So this was about the key enabling technologies in terms of intelligent meta surfaces. Then part 2 is basically machine learning and AI for ISAC. Again, very important point is how we can actually implement our machine learning and AI algorithms. Again, this is another field on its own, and how it can be actually combined, intertwined for our ISAC technology as well, right? So and then there is chapter 4, basically next in the row in part 2, basically. So you got channel estimation in these systems when you have RIS and ISAC combined together, and how you can use machine learning approaches for this channel estimation. As you know that in pre-standards and standards, it's becoming more important than ever to actually model this channel or estimate this channel for ISAC systems. So here we have combination of different technologies. You go RIS-assisted ISAC, and you want to use your machine learning and AI approaches to actually estimate your channel, to provide, let's say, high accuracy solutions, and try to really come up with the sort of best effective approach to estimate this channel, right? And this chapter has been introduced in the book by Yu Liu, Ibrahim El Nahal, Octavia Dobre, and Fanggang Wang as well. So these are our colleagues from Memorial University and different other universities as well for this particular chapter. And they try to talk about some sort of supervised machine learning channel estimation for RIS-assisted ISAC systems. Again, very interesting chapter. They discuss about different use cases. So you can have, let's say, in terms of a single user sort of case study, you can have multi-user case as well, and sort of multi-user case for another scenario as well. So they discuss different applications. So that is quite interesting to see this in the book. And then next in the row is chapter 5, which is basically how you can utilize federated learning for ISAC, right? So how you can integrate your ISAC system with federated learning, and basically in terms of wireless edge networks, right? So edge intelligence again is quite important. And this chapter is introduced in the book by Nanchi, Ming Xiao, and Carlo Fischione. So these are our colleagues from KTH in Sweden, and they talk about different sort of correlation of your federated learning and ISAC systems, and how actually federated learning can enhance the capacity for your ISAC systems. Again, very interesting chapter. In part 3, basically, so after part 2 finishes, we have ISAC waveform design and full duplexing. So that is basically the title of the part in this particular book. And we have chapter 6 on that. So that is basically on communication centric multimetric ISAC waveform optimization. Again, this is very interesting to see because waveform optimization is quite important when it comes to this joint signaling that we have with sensing and communication, right? So we have basically waveform optimization for the ISAC, but this is more communication centric and different metrics have been used. And this chapter has been introduced in the book by our colleagues Jitong Ni and Andrew Zhang. So they are our colleagues in UTS Sydney, and they talk about some sort of waveform optimization methods. So it can be weighted sum optimization, Euclidean distance optimization, threshold constraint optimization, or decoupled optimization, right? Different methods that they discuss, and they provide some case study as well around this optimization problem, and then some results and performance analysis that you get. So again, if you're really interested in sort of waveform design problems, it's a very good chapter to have a look at. Then you have next in the row is chapter 7. So this is basically waveform design with constant peak to average power ratio, so constant PAPR. Again, very catchy concept to design the waveform. So let's say you want to basically design, your average PAPR. Let's say you want to lower down the value of these, and especially for the ISAC system. So in this one, they consider a constant PAPR value for your waveform design. And this chapter is a long list of authors. These are our colleagues from University of Melbourne. So you got Rajita Sananyake, Tian Han, Shalanika Ratna, Peter Smith, Jamie Evans, William Moran, and Robin Evans as well. So these are our colleagues in University of Melbourne in Australia. So they try to discuss about some novel ISAC waveform design techniques, and also discuss about PAPR as well, what it is and how it can be sort of fundamentally included in your waveform design. And basically, they try to provide some sort of techniques as well when you talk about radar sensing and communication operations and kind of joint system design that is there in this particular book. Very interesting chapter to read. Then next in the row is chapter 8, which is detection of integrated sensing and communication waveforms. As you can see that we have more chapters on terms of waveform optimization because it's a very sort of catchy topic. So this chapter has been introduced in the book by Kaiyu Zhang, Sheng Chang, Fraser K. Coots, and John Thompson. So these are our friends and colleagues from the University of Edinburgh in the UK. And eventually John Thompson was also my PhD supervisor as well. So our collaboration goes way back. So we discuss, in this particular chapter, our contributors, they present on the design of, ISAC system and different applications, especially in terms of waveforms, right? So they try to provide some information of chirp-based ISAC waveforms, OFDM-based ISAC waveforms, OTFS-based ISAC waveforms, right? So again, this is a bit of how there's a discussion going on whether we should stick to OFDM when it's, concerning these 6G solutions we have, or we should look for new sort of waveform designs like OTFS or something else that we can come out with. So they try to provide some sort of discussion around this as well, like how we can utilize different techniques, our multiplexing techniques for waveform design and so on, right? And then they discuss about, basically non-coherent algorithm as well that they try to introduce in this particular chapter, and then, go ahead with the, sort of performance analysis and different aspects of these techniques that we have. Then we have chapter 9. So this is about the full duplexing. So how to utilize full duplex massive MIMO for ISAC. And this is introduced in the book by our colleagues George Alexandropoulos and Ionas Gavras. So these are our colleagues from University of Athens, the National and Cappadocian University of Athens, right, in Greece. And they talk about different, sort of models for full duplexing and, the architectures and, for the transmitter side and the receiver side as well. Channel modeling, for the downlink and sort of end-to-end MIMO channel as well. And how actually full duplexing, especially with the scenario of massive MIMO, can be utilized with ISAC technology itself. So they try to provide some results and discussions around this as well. I mean, quite new and quite catchy topic as well. Chapter 10, basically, next in a row is linear transmit waveform and radar receive beamforming design for joint radar communication system. So as we try to implement, good transmission designs, good, let's say, sort of transmission reflection sort of designs for our, transmitter and receiver, it becomes very very important is that we come up with some good waveform optimization. At the same time, the beamforming is also satisfied the sort of performance of our beamformers as well, right? So this work is done by Christos Gichinos, again, our colleague from Greece in University of Athens, and he discusses about different sort of, descriptions of the model, the communication side of it, and the sensing side, so radar sensing per se, and try to formulate some problem as well, try to propose a problem of the maximization of our SINR ratio that we have, subject to different constraints, so sensing constraints and communication constraints, and then they provide different numerical results and so on around the technology itself. Then we move on. So again, this was a very long part, part 3. So because waveform optimization is a very important aspect, and beamforming design as well, full duplexing too. Then we cover part 4, which is basically about exploring different frequency bands. So you have millimeter wave, terahertz, and beamforming for ISAC. So that's basically the part 4 of the book. And chapter 11, that is in this series, this is about the beamforming architectures for ISAC in millimeter wave and terahertz. So basically try to explore millimeter wave bands and terahertz bands as well. Again, as I was explaining earlier, is that we have to try this technology at different frequency bands. Again, for 6G, we consider that centimeter wave is basically the key enabler, and sub-terahertz we will try as the complementary spectrum. But it's also good to see is that for the high frequency spectrums, how ISAC is going to behave and what kind of efficient beamforming technologies we can use. And this chapter is done by our colleagues Ahmed Elbir and Simeon Chadjinotas. So these are our colleagues from University of Luxembourg. And basically they discuss about sort of a hybrid beamforming design for ISAC and sort of how to, let's say, have correction of your beam split problem as well. So that is basically the discuss, and especially at the bands of millimeter wave and terahertz. Again, good chapter to read if you're interested in this particular aspect of ISAC. And then chapter 12 is about flexible hybrid precoding for integrated sensing and communication. So again, continuing the aspect of beamforming, how you can utilize, let's say, hybrid precoder design at such millimeter wave frequencies and so on. So this chapter is done by Evangelos Voulakos, myself, and George Alexandropoulos again. So this chapter discusses about the channel models and sort of mutual information maximization, and some results have been also provided at the end of the chapter. So please feel free to sort of go through this chapter as well. Then we have part 5 in the series, which is about the network architectural aspects of ISAC, especially for the cellular systems. And in this particular part, we have chapter 13, which is about RAN architecture and implementation requirements for ISAC. So this has been, authored by our colleagues Fatame Tushara, Rath Vanitambi, and Arvind Merwade as well. So this is basically our colleagues in industry. So this was done by Intel in the US. So our colleagues, they actually were kind enough to contribute like industry aspects of the ISAC technology, and especially in terms of the RAN architecture, how it is beneficial, the open RAN, as we discussed in our previous podcast as well about open RAN and different sort of challenges related to that. So they try to discuss the overview of 3GPP and sort of ORAN architectures in this particular chapter, and how you can join sensing and communication together and basically try to provide some sort of front haul throughput that you can achieve using these aspects, and some other challenges they provide in the chapter itself. So if you want to have more industry sort of overview sort of on Open RAN and combination with ISAC, especially for your cellular system, sort of network aspects, this will be a very good chapter to read. Then we have part 6, so the second last part. So this is about multiple access and interference management for ISAC. So we have chapter 14, basically again, multiple access for ISAC. That's the title of the chapter. So we have our colleagues Kexin Chen, EJ Mao, Won Jishin, and Bruno Clerks. So these are our colleagues from different universities in China, Korea, and also the UK. So basically here they discuss about how you can utilize different multiple access approaches, right, to enable your ISAC systems. So how you move from orthogonal to non-orthogonal, and perhaps provide even better multiple access techniques as well, as suitable to your approach, the sort of objectives that you may have. So they try to discuss different metrics as well for communication, sensing, and for the joint system, and try to see how ISAC can, enable using these multiple access V2X systems, or your remote sensing, or different bands as well, millimeter wave, terahertz, edge intelligence, applications, or the sort of non-trusted network-based entities as well, how you can support this using ISAC and near field as well, and how multiple access plays a big role into all these sort of use cases and applications. Then chapter 15, we have self-interference suppression techniques in ISAC. So basically more like an overview chapter on interference, and especially self-interference. So my group as well had started to work some time ago on how we can sort of reduce or manage the interference, that comes through the, let's say, sensing side to communication side, or from communication side to the sensing side. So how we can actually manage this interference is a very important point to be considered. So not only the interference that is, from the external our environment, our surroundings, and so our channel models and so on, but also the interference that actually comes within when you're trying to use this dual function signaling. So how you can actually suppress that, that is also a very important aspect. So one of the chapters on this has been contributed by Muhammad Ali Jamshed, myself, Masoudur Rahman, and Muhammad Ali Imran. So these are our colleagues in Glasgow Uni as well, done in collaboration with myself. And basically they discuss about, classification of different techniques of these self-interference suppression techniques for ISAC. They discuss about the sort of analog digital aspects and sort of hybrid aspects as well for this, and different other methods and techniques that they mention. If you're interested, please feel free to go through this particular chapter. Now we have the last part, which is part 7. So this is basically about the conclusion and future prospects of ISAC technology. So we have one chapter, chapter 16. So this is about the standardization of ISAC and also synergies with the key technology enablers. Again, this is more like an overview and future prospects sort of chapter. So this is authored by Rohit Singh, myself, Miguel Daher, and Marco Di Renzo. So basically, this is the sort of chapter that you see, how ISAC is going to look in, let's say, next couple of years. So it provides you that sort of background on what can be the benefits of, of ISAC technology, and especially, both societal and economical benefits as well. So we discuss some, sort of methods here, some sort of, aspects more than methods. And we also discuss about some key synergies as well, like what kind of technology enablers that can be helpful to sustain this ISAC technology, and how it is working out in 3GPP and any pre-standards sort of aspects. And we also discuss about different challenges that we need to keep in mind, especially the compliance and regulatory considerations, the cost effectiveness, and the sort of energy efficiency or power management we need to consider, and different use cases and applications we can come up with using ISAC. So that particular thing is dealt with in this particular chapter. So this was basically the last chapter of this book. So I wanted to discuss about the whole book and how important the technology is, and what kind of different techniques that are ongoing regarding this particular technology of ISAC, which is a very important technology, as we can see that is included in all the sort of standards activities, and in our 3GPP release 19 recently, you can see different system aspects working around these topics that are for this technology, and it has been being updated as well as we are proceeding, as we are evolving step by step. So here we go. I think this was all about the book, and I would like to thank our sort of contributors, the chapter contributors. Again, their work was immense to make this book a successful publication. You can find this, online, like a digital copy. You can also find the book in terms of the hard copy as well, if you're interested in these chapters that I mentioned, in these contributions from our collaborators that I've mentioned, and in general, if you're really interested, about the technology itself. So we try to provide different sort of scenarios, aspects, related to the technology itself. So you're very much welcome to go through the book and also learn about the technology more. My group and I, we have been working quite a lot on this technology now, and multiple other technologies and sort of synergies and combinations of these all together. So again, I would like to thank our contributors, my group as well, and basically thanks the publisher as well. So to actually publish this book and basically make it available for the public to access as well. So with that, I would like to conclude my podcast. So we will see you in the next podcast. We have a very good series planned ahead, and basically we will have more guests and so on. So we very much look forward to see you in the next podcast. So thank you so much, and take care.